So this is the video for part 3 of assessment 1. So with the OSI TCP/IP models, um, the information starts at the application layer of the sending side, so like a web browser or email client or something. Then the data flows down, as you see in this diagram. It flows down to the physical layer of the sending side, and then goes over to the receiving side's physical layer, and then works its way back up to the application layer, so the user on the other side can read it. This TCP/IP model looks a bit different, but it works in the same way, like the data flows down the same directions. So some basic operations and protocols of this model. The physical layer has connectors such as the cabling, the adapters, and network cards, and the system components and all that. The data link layer lets the device access the network to send and receive messages and assigns a physical address. The network layer assigns a logical address so data can be routed across layer 2 networks. The transport layer offers end-to-end communication between devices to the network. The session layer provides various services. Some of its functionalities include synchronizing data flow, acknowledging data was received, retransmitting data if it wasn't received properly. The presentation layer is responsible for how the application formats the data. So basically, so the application layer can read the message. The application layer is the visual interface for the user operating the device, so like web browsers and stuff like I said before. What's next? Explain the need and the role of IP addressing. A unique IP address is assigned to each device so information can be sent to that address and be received by that device. It can easily be compared to a phone number where the number is used to communicate with you directly. Yeah, and if IP addressing wasn't there, then the device wouldn't be able to send or receive any information. It's important that your intermediary devices, like routers and switches, are secured properly, physically. Otherwise, physically, if people get into them, they could reset the password, and they would just have full access to the router. And they could also just steal it or damage the devices. And it's important for the devices to be passworded with secure passwords, which have to be put in for the login mode and the privilege mode, and don't make them the same. Otherwise, it's kind of pointless having to make them like both very secure passwords. And it's important that they're secured properly. Otherwise, information could get stolen, and then some people could use it for like malicious intent. Like some people have like extort companies or like release the information to the public, stuff like that. Network segmentation is subnetting, pretty much splitting the network into subnets, which has multiple advantages like reducing congestion, improving security, and containing problems, so like making troubleshooting easier. Bandwidth is basically the amount of data which can travel through at once. So if on your home network, if people are downloading or streaming, there's going to be less bandwidth. And then, yeah, there'll be less bandwidth, and then people won't have the best speeds that they could have. And there's also issues with broadcast traffic sometimes, like when there's a bunch of requests at once. So for example, like if thousands of people are accessing a web page at the exact same time, or something like that. Router functionality. In routers you can manage how much bandwidth the device has, and like what priority the device has, or even ban it from using the network. To create a routing table, the routing information protocol is used, which automatically creates and updates a routing table. And down here are some basic router commands. So enable enters the privileged exec mode, hostname, and then you type the name afterwards, hostname. Changes the name of the routers. enable secret and then enter a password. Sets an encrypted password. And to change the IP, you type interface and then the type of it and the number. So interface fast Ethernet 0. And then once you do that, then you do IP address and then enter an IP address and a subnet mask. So for example here, you see IP address, subnet mask. You do no shutdown, which changes the state from down to up, which enables everything. To put it simply, switches allow devices on a network. Yeah, basically switches just allow devices on a network. Sorry, switches on layer 3 allow devices on a network to communicate, much like how routers are used for networks to communicate with each other. In a lot of cases, switches have Ethernet ports, but other types exist as well, like fiber. Some like fiber switches exist, but they're not common at all. Most of the time, switches are part of layer 2, but in the case of it being layer 3, it uses IP addresses rather than MAC addresses. So this means when switches are on layer 3, they act a lot like a router, which just doesn't have WAN. So a lot of time, layer 3 switches are used as subnet big Ethernet networks. A public IP address is an IP address for your network, which is given to you by your ISP. And it's unique from all the other addresses on the internet. And then a private IP address is an IP address which is used, which is issued to a device by a router, so it can be identified within the network. To find what routers are used for the assignment, I searched for routers within a reasonable price range and chose a wide range to choose from, like as far as pricing and specifications such as like speed and the amount of ports. I just made sure to choose some variety in the price and the specifications to have a good selection to choose from. And what ended up happening was actually chose the second most expensive router rather than the most expensive, because it had slightly lesser specifications, like it had a 0.4 gigabits less speed, and it had 6 ports rather than 8, but it was still good enough for the scenario, so it ended up saving $150. And summarize different WAN connections options. So there's over the internet, so like cloud stuff, I think that is. So it's like the least expensive way, but you need to use the VPN because it's not secure at all. And there's leased line, which is the most secure since it's a direct connection between two networks, like through Ethernet or fiber optic or stuff like that. Though it is really expensive because of all the cabling and the installation of the cabling. Circuit switching is a circuit path created between all the points. Sort of like leased line, but it's less expensive because it creates it between a bunch of different points. And a packet switch, packets are transferred via a shared single point-to-point link, which is just a good use of bandwidth. Just whatever way is used, the result's always the same. It just lets the different locations communicate with each other.